Head is a measurement of the energy possessed by the water at any particular location in the water system. Head is used to calculate the hydraulic forces acting in a pipeline and to determine a pump's capacity to overcome or pump against these forces. 1 foot of head is equal to 0.43 psi, or 2.31 feet of head equals 1 psi. Make sure you know these conversion factors, as water operators often need to convert back and forth between psi and head. If we have a pressure gauge reading of 14 feet, how many psi is that? We take the 14 feet divided by 2.31 feet per psi. The feet cancel out and we are left with 6.06 psi. If we have a head reading of 250 feet, what is the psi on the pressure gauge? It's basically the same calculation. If we want to know psi, this is going to equal head and feet divided by 2.31 feet per psi, which equals 108 psi. To determine head in metric units, we need to know that there are 0.102 meters per kilopascal of head. Therefore, if we have a pressure gauge reading of 210 kilopascals, we take 210 kilopascals times 0.102 meters per kilopascal. The units cancel out, resulting in an answer of 21.4 meters of head. Next, we will look at force. Force is equal to mass times acceleration, or pressure times area. If we have a pressure of 12 psi over a surface area of 120 square inches, what is the force? Using our equation, 12 psi times the 120 inches, the inches cancel, and that leaves us with 1,440 pounds of force on that particular area. Let's try another pressure calculation. If there was a pressure of 55 psi on a surface that is 1 foot by 2 foot, what is the force on the surface? Now keep in mind, the pressure is in units of psi and the area is in units of feet. So we need to do a unit conversion of feet to inches. Our area is then 12 inches by 24 inches, or 288 square inches. So now we can take the area times 55 psi pressure, and that gives us 15,840 pounds of force. Another instrument that is used to measure water pressure head is a piezometer. Think of it as a water level used on a larger scale. What happens if we have an elevated tank connected to a tank that is down on the ground? Assuming the ground tank has a top to keep water contained, the water is going to come out of the elevated tank and go into the lower tank under pressure, and we can determine that the pressure will rise to approximately the same level that is in the elevated tank minus any friction loss. Does this work if we have a series of piezometers on a pipeline and an elevated tank? Let's find out. Here we have an elevated tank and it has a pipeline that is going off to the right-hand side. And let's assume we have 4 piezometers. 3 of them are before a valve and the valve is closed. What is the height going to be in the piezometers? The first 3, because they are connected directly to the tank, are going to be at the same level. Once you open the valve though, the pressure depends on what is downstream. This red line is called a hydraulic grade line. Generally, we use feet with tanks and convert to psi. The result is going to tell you, based on the flow through the pipelines, how much pressure you have at any given point in your distribution system.